Hello, this is video number 9 on my single variable calculus 2. In this video, we're going to talk about natural exponential and natural logarithm. First, we're going to talk about some of the properties of natural exponential and natural logarithm that you have seen. So this is going to be mostly a reminder. If you look at the graph of e to the power of x and graph of ln of x, these two functions are inverses of each other. Graph of e to the power of x passes through 0, 1, and it is exponential, so it goes to infinity as x goes to infinity. It goes to 0 as x goes to negative infinity. So this is y equals e to the power of x. Graph of logarithm is the reflection of this about the line y equals x, and it looks like this. So it passes through the point 1, 0. Natural log of 1 is equal to 0. And as x goes to infinity, natural log goes to infinity. As x goes to 0 from the right, natural log goes to negative infinity. Derivative of exponential is itself. Derivative of logarithm is reciprocal. Integral of e to the power of x is e to the power of x plus c. And integral of 1 over x is natural log of absolute value. So when you're integrating 1 over x, you have to be careful. The integral would be natural log of absolute value of x. So these are things that you have seen before. Now, if you apply the chain rule to exponential, derivative of e to the power of f of x becomes exponential e to the power of f of x times the derivative of inside. So it is f prime of x. So let's do a few examples on that. So we want to find the integral of square root of 1 minus 5x. So if you look at this one, really the difficulty with this integral is the square root. So how do we get rid of that square root? Well, what we can do is we can put this square root as an exponent of 1/2. So this would be 1 minus 5x over 2. And then we can do a u substitution for 1 minus 5x over 2. So du becomes minus 5 over 2 dx. So dx becomes negative 2/5 du. So plug in that here, we get e to the power of u. Dx is negative 2/5 times du. Now we can put the negative 2/5 out. And integral of e to the u is e to the u plus c. And putting the values back, we get negative 2/5 e to the power of 1 minus 5x over 2 plus c. So this is the given integral. So let's look at the second integral. The second one is e to the power of cosine x sine x. As we see, derivative of cosine is sine, which is right there inside the integrand. So we can take a u substitution for cosine. So let's do u equals cosine of x. Du is negative sine x dx. When x is 0, u is 1. And when x is pi, u is negative 1. These are the limits of integration that they gave us. So this becomes integral from 1 to negative 1 e to the power of u, and sine x dx is negative du. So the integral of that is negative e to the u, and then we have to evaluate it from positive 1 to negative 1. We plug in negative 1, we get e to the power of negative 1, or negative e to the power of negative 1, minus negative e to the power of 1. So the answer would be e minus 1 over e. Finally, the last integral is integral of dx over 1 plus e to the power of negative x. So this is integral from 0 to 1, 1 over 1 plus e to the power of negative x dx. So we're going to multiply by e to the power of x to get rid of that negative exponent. So this would be the integral from 0 to 1, e to the power of x over 1 plus e to the power of negative x times e to the power of x. So in essence, I'm multiplying this fraction by e to the power of x over e to the power of x. So this becomes e to the power of x over e to the power of x plus 1. Now we notice that derivative of e to the power of x plus 1 is e to the power of x, which is right there. So we can take a u sub for e to the power of x plus 1. Du becomes e to the power of x dx. When x is 0, u is 2. When x is 1, u is e plus 1. So this is the integral from 2 to e plus 1 of du over u. We can use the integral of 1 over u, which is natural log of absolute value of u, and then we have to plug in the values from 2 to e plus 1. Now both e plus 1 and 2 are positive, so we don't need the absolute value. And that is our answer. And we can combine these two, natural log of e plus 1 over 2. So this is our final answer. Okay, let's look at another example. Evaluate the derivative of this function. So this is e to the power of a function. So what's the derivative of e to the power of x sine x? Well, we have to use the chain rule. So we get e to the power of the function times derivative of the inside, derivative of x sine x. So this becomes e to the power of x sine x times sine x plus x cosine of x. So that is the answer to this derivative. Okay, let's look at the second one. The second one, unfortunately, the base is not e, so this is more difficult. There are two different methods for solving this one, and I'm going to explain both of them, and then you can decide which method to use. Method number one is to turn the base into e. So how do we turn the base into e? Well, x is e to the power of natural log of x, because exponentiation and natural log are in fact inverse of each other. So if you apply natural log and then apply exponentiation, you go back to x itself. When we have exponents one after another, we can multiply the exponents. So this would be x natural log of x. And then when you want to differentiate this, we can now use the derivative of exponentiation. So this would be e to the power of x natural log x times the derivative of the inside function. Now, e to the power of x natural log x, based on what we discussed here, is in fact x to the x, and derivative of x natural log x is 1 times natural log x plus x times 1 over x. So this would be x to the x times natural log of x plus 1. So this is the derivative of x to the power of x. There is another method which is called logarithmic differentiation. So this method is something you learned in Calculus 1. So what is logarithmic differentiation? Logarithmic differentiation is used when you have either exponents and bases that are both functions, or you have large products. So here is how we apply that. Y equals x to the power of x. We take the natural log of both sides. We get x natural log of x. Then we differentiate both sides. So we get 1 over y times y prime. Derivative of x natural log x is 1 natural log x plus x times 1 over x. Next, we are going to multiply by y. We get y prime equals y times natural log of x plus 1. And once we plug in back x to the power of x, because y is x to the power of x, we get x to the power of x times natural log of x plus 1. This is the derivative of x to the power of x. And that's exactly what we got before. So in general, to find the derivative of f of x to the power of g of x, you write down f of x as exponential of natural log of f of x. And then we multiply the exponent, so we get natural log of f of x times g of x. Then we apply the chain rule. We get e to the power of f of x, natural log of f of x times g of x times the derivative of the exponent. And derivative of exponent requires us to use product rule. So we have 1 over f of x f prime by the chain rule, that's the derivative of f natural log of f of x times g of x plus natural log of f of x times the derivative of g of x. I would not memorize this formula. It's not very difficult to drive this formula. Okay, so now we are going to look at the other method. The other method is logarithmic differentiation. So what is the logarithmic differentiation? You take the function f of x equals to the power of g of x, set that equal to y. You take the natural log of both sides, so you get natural log of y equals g of x natural log of f of x. Then you differentiate both sides. You get 1 over y times y prime equals g prime natural log of f of x plus g 1 over f of x times f prime. This is the derivative of natural log of f of x. And then you solve for y prime by multiplying both sides by y. And eventually you sub back f of x to the power of g of x for y. So let's do one last example on this one, and then we will summarize. Evaluate the derivative of this one. So we're going to set y equals sine of x to the power of cosine of x. I'm going to use the logarithmic differentiation. So log of y would be cosine of x, natural log of sine of x. Then we are going to differentiate both sides. We get 1 over y times y prime using the chain rule. On the other side, we get negative sine x times natural log of sine x plus cosine of x 1 over sine x times cosine of x. So that tells us y prime is y times negative sine x natural log of sine x plus cosine squared x over sine x. Now y is sine x to the power of cosine x. So this becomes derivative of sine of x to the power of cosine of x becomes sine x to the power of cosine of x times negative sine x natural log of sine x plus cosine squared x over sine x. So that's the final answer. So to summarize, what we learned was how to differentiate f of x to the power of g of x. Most of these were reviews from Calc 1. So to evaluate the derivative of f of x to the power of g of x, we may use logarithmic differentiation. So you said y equals f of x to the power of g of x. You rewrite that by taking the natural log of both sides. You get natural log of y is g of x times natural log of f of x. Then you differentiate both sides. You use the chain rule to get 1 over y times y prime. You use the product rule to get g prime of x, natural log of f of x, and g of x, and then chain rule gives you 1 over f of x, f prime of x. And then you multiply by y, and then you substitute f of x to the power of g of x back into y. And that brings me to the end of this video. So I will see you in the next video.